part 3. So yeah, so we were here, right? So this will model or compile optimizer that we have to use is our RMS prop, and for the accuracy and for the loss and appropriate loss function we have used already the categorical cross entropy, which is loss function, and then for the accuracy we are using metrics, which is mentioned, right? And accuracy for your metrics. So this is done. When we compile this, it's all good. Now we have to fit your model using epoch and batch equal to 10. So for fitting, like what exactly fitting do? It is implemented by every estimator and accepts an input for the sample data and for supervised model, and it also accepts an argument for labels, right? Optionally, maybe like it can also accept additional sample properties such as weights. Methods are usually responsible for numerous operations, right? Fit the data, right? So what exactly now epoch and batch does? So epochs are the number of epochs, number of complete passes through the training data set, how many passes they complete, and for the batch size, the number of samples processed before the model is updated. Before the model is updated, it's the number of samples processed, right? So for that we are using model.fit xtrain. What we have to fit is one hot train labels epochs should be 20 and batch should be 10. So when we run this, it will give us 20 epochs, and batch size when it's updated it will give us 10, right? Okay, now please calculate the result evaluating. Okay, now we have to calculate the result and see how accurate your model works, right? For that we are using test loss and test accuracy. To calculate that we have to evaluate excess and one-hot test labels, which will, if we print that test loss and test accuracy, so it will give us the accurate result. This is the test loss and the test accuracy. 5 out of last 5 calls, right? So now we repeat all we have done. The same thing we have to do again, the same steps from comparison formula, same thing, sequential. We are using dense again, the shape, and use the same setting as you have done for, okay, we are using the same compile phase using etc. So we are compiling the same thing that we done in step 6 that I have already discussed. So now please fit your model. Again we are fitting the same. Now we are using 4 epochs. For the 4 epochs, batch 10 is same, but now 4 times the it will run, right? So here it is. So how accurate it gives the accuracy is this, how loss, what was the loss function, yeah, so it looks like that. Now we have to please calculate the result evaluating your x-test one element and see how accurate your model works. So it's the same thing, we have to evaluate the things now. Yeah, once we evaluate the same thing that we did before, it's the same value it will come, right? Now the next step, please explain. Okay, these are some questions. Okay, how the numbers of layers or hidden units could impact the accuracy of a model. Increasing the number of hidden layers might improve the accuracy or might not. It depends, right? It usually depends on the complexity of the problem sorry that you are trying to solve. It depends on like how we solve a problem, right? Do we always suffer from, no, it's not necessary, right? Overfitting occurs if we are not careful and try to over train our model. So that's why overfitting occurs. So it's not necessary that we always suffer. Overfitting can come like if we are very careless about the model, right? How can we find and manage overfitting? By determining whether your model fits new data as well as it fits the data used to estimate the model. So it depends like how we manage the overfitting. So to run that, we have to imply the same thing that we assessed in the question 9. Same thing, we are importing, we are testing, we are getting the valuation, epochs and runs and the model compilation. So when we run this, it will give us the exact result. But we are doing like, it depends on us how many epochs or batch we have to do. So for that I tried 70. Sorry.